Think about the last time you flew. At some point during the flight, without warning, the plane shook. Maybe it was gentle. Maybe it was strong enough to make you grab the armrest. Maybe you glanced at the flight attendant to see if her expression changed. And most likely, you didn't quite understand what had happened. No one explained it to you. The pilot spoke over the intercom with his usual calm demeanor. "We are about to enter an area of unstable air. Please remain seated with your seatbelts fastened." And he continued on. And you were left with that strange feeling in your stomach. Not exactly fear, just being inside something you can't control and that no one has fully explained to you. What no one has told you is that the turbulence you experienced is becoming increasingly common, and that pilots, with all the technology at their disposal, are finding it increasingly difficult to anticipate it. In the next few minutes, you'll understand exactly what happens when an airplane shakes, why it's happening more than it did 10 years ago, and why the most dangerous type of turbulence in the world is completely invisible, not only to passengers but also to the pilots themselves. There's a fact at the end of this video that will change the way you board a plane. Not because you'll be more afraid, but because you'll understand something that no one has ever explained to you before. When you feel turbulence, the first thing your brain does is look for a visual explanation. You look out the window. You look for dark clouds, rain, anything to justify what you just felt. And often you find it. There are clouds, there's bad weather, the plane has flown through it, and that's it. For decades, pilots worked with that same logic. Radar detects water, water is in the clouds. Clouds mean turbulence. We fly around the clouds, and that's it. It was a system that worked reasonably well. But there's a type of turbulence that has no clouds, no rain, no visible signs. The sky is clear, the sun is shining, and the plane suddenly drops. It's called clear air turbulence. And the real problem isn't that it exists. It's that it's happening more and more every year. And it's completely invisible to passengers and extremely difficult to detect, even for pilots. Think of river water. When two currents meet in opposite directions, a whirlpool forms. You see it, you avoid it. Now imagine that same phenomenon at 11,000 meters. Two gigantic air masses moving in different directions, at different speeds, colliding silently and without leaving any visible trace. That's exactly what happens in clear air turbulence. The aircraft's radar can't see it because there are no water particles to detect. By the time the instruments register the effects of that disturbance, the aircraft is already in it. And at 900 kilometers per hour, in it means right now. Pilots describe it as something unlike anything on the ground. It's not like a pothole in the road. It's more like driving along peacefully and the ground disappears beneath your wheels for 2 or 3 seconds, without warning. Without any chance to react. Now think about what you do in that moment. You probably have your seatbelt fastened because the sign has been on for a while. Or maybe not. Maybe you are leaning forward, searching for something in your backpack. Maybe you just got up to go to the bathroom because you hadn't encountered any turbulence for hours and everything seemed perfectly calm. And it's precisely at that moment that clear air turbulence becomes most dangerous. And here's the fact that most unsettles the airline industry. A study published in the scientific journal Nature in 2023 analyzed decades of flight data over the North Atlantic, the same route that connects Europe to America, the same one that many of you watching this have flown at some point. The conclusion was this: severe, clear air turbulence has increased by 55% in the last 40 years. Not 10%, not 20%, 55%. Think about that for a second. If you had flown the exact same route 40 years ago, the probability of encountering this type of turbulence would have been considerably lower. Today, pilots face it more than ever. And the most unsettling thing isn't the number. It's that the trend continues in the same direction with no signs of slowing down. And now comes something you've probably never considered. If this has been increasing for decades, why aren't there more serious accidents? Why aren't the planes breaking down? The answer has 2 parts. One will reassure you, the other not so much. The reassuring part first. Modern airplanes are built to withstand forces far exceeding those generated by any turbulence encountered in normal operations. An Airbus AA350 or a Boeing 787 is designed with ample structural safety margins. The most severe turbulence recorded in commercial aviation remains well below the limits for which these aircraft were designed. The plane isn't going to break. That's something aeronautical engineering has been guaranteeing for decades. The problem isn't the plane. The problem is you and me and anyone who at some point during a flight unfastened their seatbelt because the sign went off. Every year, hundreds of passengers and crew members are injured in unexpected turbulence. The vast majority have something in common. They weren't wearing their seatbelts. A flight attendant collecting trays. A passenger who went to the restroom just before the jolt. Someone who had been wearing their seatbelt loose for hours because the flight had been completely smooth. In May 2024, a Singapore Airlines flight from London to Singapore entered an area of severe turbulence over the Indian Ocean. The sky was seemingly clear. There was no apparent warning for the passengers. Within seconds, the plane was violently shaken. One passenger died. Dozens were injured, several seriously. Investigations pointed to clear air turbulence, a phenomenon that can occur where there is seemingly no visible threat. Perhaps you remember seeing that news report. Perhaps at the time you thought it was an exceptional case, something that couldn't happen to you. But if you've ever flown on a long flight and unbuckled your seatbelt because you'd been flying for hours without turbulence, you've been much closer to that situation than you imagine. Then the obvious question arises. If we can't see it and we can't completely avoid it, is anything changing? Is anyone working on this? The answer is yes. And part of the solution comes from where you least expect it. From the very planes that are already flying right now. The curious thing is that part of the solution is already flying over our heads right now. Every plane that flies through an area of turbulence automatically becomes a scout. It detects the problem, records it, and helps warn planes behind it. When you felt that jolt on your last flight, that information reached other pilots following you within minutes, without anyone telling you, without anyone asking you. It's a system that works, but it has a limit that no technology has yet been able to overcome. Turbulence in clear air can appear and disappear in a matter of minutes. By the time the warning arrives, the conditions have already changed. It's like trying to avoid something that's moving faster than you can communicate it. And there's something even bigger behind all of this. Something that explains why this problem isn't going away anytime soon. Think about the last transatlantic flight you took. If you flew from America to Europe, it probably took less time than expected. If you flew back, it probably took longer. That difference of almost 2 hours is caused by one thing: the jet stream, the enormous current of air aloft that circles the planet. It's the same current that airlines have been using for decades to save fuel. For years it was stable, predictable, almost like an invisible highway in the sky. But that's changing. The Arctic is warming faster than the rest of the planet. And the temperature difference between the North Pole and the equator is one of the forces that helps keep that enormous current of air orderly. But when that difference narrows, the jet stream starts to behave less regularly. It makes larger curves, shifts more than normal, and changes position with less warning. And when that current becomes more unstable, collisions between air masses moving at different speeds also increase. More invisible collisions, more turbulence in clear air, more tremors on routes that for decades seemed completely calm. So the next time you are on a flight and the plane shakes in the middle of a completely clear sky, you'll know exactly what's going on. It's not the pilot not knowing how to fly. It's not a problem with the plane. It's physics. Invisible masses of air moving at enormous speeds and interacting with each other in a constantly changing environment. And there's something worth taking away from all of this. For years, the feeling of safety on an airplane came from what was visible. If there were no clouds, there was no problem. If the flight had been calm for hours, there was no risk. If the seatbelt sign was off, you could completely relax. But turbulence in clear air breaks that logic. Danger doesn't always give warning. It doesn't always come in the form of a dark cloud or a gray sky. Sometimes it arrives at the calmest moment of the flight, when everything seemed to be under control. Airplanes are safer than ever. Engineering is more advanced than ever, but the sky they fly through is becoming less predictable. And that combination, extraordinary machines navigating an increasingly complex environment, is the great challenge for aviation in the coming years. The paradox is that we have never built machines so safe to traverse such an unpredictable environment. And that is something that no current technology can yet fully resolve. There is one thing you can do. One thing that doesn't depend on technology, pilots, or meteorologists. Keep your seatbelt fastened. Not just when the sign is on. Every time you're seated. Because the most damaging turbulence is precisely the kind that doesn't give any warning. And the next time someone next to you unfastens theirs because the flight has been calm for hours, you'll know something they probably don't. If the world of aviation sparks your curiosity, the following video will surprise you even more. It's right here.